Alrighty, let's go ahead and discuss Lesson 6.3 notes, rectangles, rhombi, and squares. So these figures, what we're dealing with today, these are special types of parallelograms. So then, if these things are parallelograms, well, first we got to understand what parallelograms are. So parallelograms, remember, those are quadrilaterals with two pairs of parallel sides. And they have these properties. Well, one of them was, if we go back to the old notes, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and if one angle is right, then all the four angles are right, okay? Those are the first four properties that we were talking about. And then we also talked about the diagonals of parallelograms, right? If the diagonals bisect each other, they bisect at the midpoint, right? And we can consider that, we can say that segment AP is congruent to segment PC, and segment BP is congruent to segment PD, And then if we have, if quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles and such, okay? So those were the properties that we were talking about from the last unit. So what I want to go ahead and do is I want to talk about these special types of parallelograms. And one of the parallelograms that you have to know is a rectangle. A rectangle is basically a parallelogram with four right angles. So it's a parallelogram with four right angles. Okay, so you're going to have to believe me on this. We have a quadrilateral, 1, 2, 3, 4. These sides are parallel. These sides are parallel. So it is indeed a parallelogram. But this parallelogram has four right angles, which we will call a rectangle. And the properties of the rectangles, all four angles are right angles, and the diagonals are congruent and bisect each other. Okay, so here I have my rectangle. These diagonals, they bisect each other at a midpoint, okay? Meaning that this segment here is congruent to that segment. So I'm going to go ahead and draw a tick mark there and a tick mark there. And since this is the midpoint of this segment as well, right, then that means that this segment has to be congruent to that segment. But what did we say at the beginning? The diagonals are congruent, okay? So these diagonals are congruent to each other. So the question you might ask is, how many tick marks do I draw here? Well, I don't draw two, I actually draw one, okay? Because this segment is also congruent to that segment. This segment is congruent to that segment due to the fact that these diagonals bisect each other and are congruent, okay? So those are the properties of rectangles. Let's talk about what a rhombus is. A rhombus is a parallelogram with four congruent sides. Okay, so if I look at my rhombus right here, 1, 2, 3, 4, quadrilateral. This segment congruent to that segment congruent to that segment. Well, actually, all of these sides are congruent because we can look at the tick marks here, right? We're so used to saying, oh, it's parallelogram, opposite sides are congruent. Yes, that is true for a rhombus, but specifically, all the sides are congruent for a rhombus, okay? Let's go ahead and talk about the diagonals of a rhombus. Now, if a parallelogram is a rhombus, then its diagonals are perpendicular to each other, okay? So suppose I have these diagonals, then that means it's going to intersect at a 90-degree angle. It's going to intersect at a 90-degree angle. So if parallelogram ABCD is a rhombus, then we could say that segment AC is going to be perpendicular to segment BD. So segment AC is perpendicular. Segment AC is perpendicular to segment BD, okay? And remember, the symbol here means that they intersects at 90 degrees. That's what it means. All right, let's go ahead and take a look at theorem, 6.16 here. Each diagonal, so if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles, okay? So if I look at this, okay, well, here are my diagonals, okay? So I got diagonal 1 and diagonal 2. Just going to go ahead and focus on one diagonal, okay? So let's take a look at this diagonal here. What that diagonal is going to do is this angle P is going to be split into two congruent parts. Okay? What do I say? Well, I say that angle 1 is congruent to angle 2, right? And then over here, angle 3 is congruent to angle 4. And the fact that these angles here are congruent, well, I don't really need to draw different arcs in this case. And that's the same idea with this diagonal, okay? With this diagonal, it's going to split angle N into two congruent parts. So I have these two congruent parts here and these two congruent parts here. And then opposite angles are congruent because that's one of the properties of parallelograms. Those angles are going to be split into two congruent parts. So angle 1, congruent to angle 2. Okay? Angle 3 is congruent to angle 4. Angle 5 is congruent to angle 6. And then angle 7 is congruent to angle 8. A square. Now, a square is a parallelogram with four congruent sides and 4 right angles. Okay, so the sides are congruent and it has 4 right angles. Now, due to the fact that the definition of a square makes it both a rectangle and a rhombus, it has all the properties of both. So to recap, the diagonals are congruent. Okay, that basically came from the square. The diagonals are bisectors. They split those, angles. They bisect those angles into two congruent parts. Okay? And then lastly, diagonals are perpendicular. Okay, and that came from the rhombus idea. So the diagonals are congruent, that came from the rectangle. The diagonals are bisectors, that came from the rhombus. And the diagonals are perpendicular, that came from the rhombus as well. So let's take a look at some examples. We're going to go ahead and use this to answer the rectangle question. Because here, number 1, quadrilateral JKLM is a rectangle. So if I were to take a look at my rectangle, I know that, well, first of all, what I want to go ahead and do is I want to mark my picture. This is a rectangle. And with rectangles, diagonals are congruent, okay? It says right here. The diagonals are congruent and they bisect each other. Second, all 4, and you should remember that, all 4 angles are right. Okay? So these diagonals are congruent to each other. So first of all, the diagonals, they bisect at a midpoint P. That means that this segment is congruent to this segment, and since the diagonals are congruent to each other, I only need to draw 1 tick mark for, those segments each. And all of those angles are right. 90 degrees each. So I have everything marked. Let's go ahead and take a look at this. JP is 3y minus 5. So this is, 3y minus 5. Okay, that's JP. And then MK is this whole thing right there. That's going to be 5y plus 1. So this whole thing is 5y plus 1. So what do I notice? Well, if this whole thing here is 5y plus 1, and this, this part here is 3y minus 5, y'all, this is basically, because I know that the diagonals are congruent. So this this whole thing here is congruent to this whole thing here, okay? So that means that this is congruent to this. but they're not on the same diagonals. But again, they are congruent. So if we look at this, it's basically, if I said that, okay, this segment here is basically that one tick mark, right? And if if I had another 3y minus 5, so basically what I'm trying to say is you need 2 of these to get you this whole diagonal, if that makes sense. So you would have to say you need 2 JPs to equal MK. Because look, here's MK, that's 5, 1 plus 1. That's that whole thing right there. And then here's JP, that's 3y minus 5. That's literally half of that. You need 2 of these to equal that. That's what I'm essentially trying to say. So how do we write this? How do we set up the equation? Well, you need 2 3y minus 5s to equal your MK, which is 5y plus 1. And if I use the distributive property, 6y minus 10, which is equal to 5y plus 1, okay, well, that's going to give me, well, if I subtract both sides by 5y and add both sides by 10, you get y is equal to 11. Okay, so that's your answer. Y is equal to 11. And then here, I'm going to go ahead and look at JKL. So here is, how do I read this? It's JKL. It's referring to that angle. JKL is currently 5x plus 15. Okay, so this angle here is 5x plus 15. But note that that angle is also 90 degrees, right? We can see it. This is also 90 degrees. So what can I say? I can say that 5x plus 15 is equal to 90. And then I get 5x is equal to, what is that going to give me? 75? So x is equal to 15. Okay? So that's your answer. That's how you find x. Now, let's go ahead and take a look at these rhombi here. And remember the diagonals of a rhombus. Remember that the diagonals of a rhombus, they're perpendicular, and they also bisect angles, So if I were to take a look at quadrilateral FGHJ, which is a rhombus with diagonals intersecting at K, use the given information to find each measure of value. Note that A, look at this. A is saying that if measure angle FJH is 82, so this angle here is 82 degrees. My goal here is to figure out what KHJ is. So KHJ. What is this angle I'm looking for in red? That's my goal. I'm trying to figure out what that is, okay? Well, first of all, what did I say at the beginning? The diagonals of a rhombus is perpendicular, okay? And they bisect the angles. So that means that, okay, well, these diagonals will intersect at a 90 degrees. So this is 90 degrees, this is 90 degrees, this is 90 degrees, and that's 90 degrees, okay? And we know that this whole angle here is 82, and this diagonal is going to split that 82 into two congruent parts, okay? So it's basically saying, what's half of 82? Well, half of 82 is 49. Okay, so if I were to redraw this triangle, what do we have? Because I want to go ahead and look for that angle, KHJ, which is this part right there. We got that 90 degrees, we got that 90 degrees, and then we got that 49. So what the heck is that angle right there? Well, we know that the sum of the interior angles of a triangle is 180. So I can just do 180 minus 90 minus 49, or is that whoa, what am I doing? Oh, I'm so sorry. This is not supposed to be 49. This is supposed to be 41. And then this has to be 41 over here as well. Okay, sorry, I was confusing. So that's 41, which is actually going to give me 49 degrees. Okay, so that's the answer. That's how you figure out measure angle KHJ, which is 49 degrees. Okay, let's go ahead and take a look at B. If measure angle GHJ is 110, so this angle here is 110 degrees, okay? My goal here is to look or find measure angle HGK. So that's, where's HGK? HGK. Well, the same idea. I know that the diagonals of a rhombus, they're perpendicular and they bisect angles. So I can go ahead and draw a 90-degree angle for that one. And maybe I can draw a 90-degree here as well if I wanted to. And note that this diagonal is going to split that 110 into two congruent parts. So that's going to be 55. So what am I looking for? I'm looking for HGK. So again, this is HGK. This is the angle that I'm looking for. Sum of interior angles of a triangle is 180 degrees. So if I just subtract from 180, I do 180 minus 90 minus 55, and it's 35 degrees. This angle is 35 degrees. So the measure angle HGK is 35 degrees. Okay? All right, let's go ahead and take a look at C. So I know that the measure angle GKH is 12x minus 6. So this here is 12x minus 6. 12x minus 6, okay? Remember, once again, diagonals of rhombus is perpendicular. So this has to be 90 degrees. This has to be 90 degrees, right? So if that 12x minus 6 is that 90 degrees, I can just set them equal to each other. So 12x minus 6 is equal to 90. And then go ahead and, you get 12x is equal to 96. So x is equal to 8. That's your answer. Okay, pretty easy. GH, we know that GH is x plus 9. And then JH is 5x minus 2. Remember, what are we dealing with? These quadrilaterals here are rhombi. So we can assume that this figure is a rhombus. That's given to us. We can use those properties that we've already discussed, which is, I'm trying to find that one. Boom. Actually, we can just look at the definition. It's already there. A parallelogram with four congruent sides, right? That means if I look at this, figure, oh, this side here is congruent to that side. This side here is congruent to that side. I don't need to draw any more tick marks because all of the sides are congruent. They're equally the same. So that means I can set these expressions to each other. So x plus 9 is equal to 5x minus 2. So then if I were to do the math, I'm like, okay, well, 11 is equal to 4x, and then that's going to be x is equal to 11 over 4. Or if you want that as a decimal, you can say 2.75. That could be your answer as well. And that's pretty much it for that one. Okay? Here, this is great. Quadrilateral PQRS is a square. So what can we say about a square? Well, it has all the properties. Okay? The diagonals bisect, and they are congruent. All angles are right. All sides are congruent, so on and so forth. So let me go ahead and just take a look at these individual parts. We know that PM, let me go ahead and write this. PM is 5, so this here is 5. Why? Because it says right here, if PM is 5, find each measure. SM. What's the length of SM? Well, what do we know? We know that since a square has the same properties as a rectangle, right? The diagonals are congruent and they bisect each other at a midpoint. that means that this segment here is congruent to that segment. And again, since the diagonals are congruent, well, this segment is congruent to that segment, and they all get the same tick marks. That, to clarify, this is 5, this is 5, this is 5, and this is 5. So how long is SM? Well, that's actually just 5. Okay? SM is equal to 5. And I'm going to go ahead and make a note. Diagonals bisect and congruent. Okay? Let's go ahead and figure out what, let's go ahead and do C first before I, do B. And maybe I should do C, D, and then B, because B is a little weird, and it requires me to, explain it more, if that makes sense. So, measure angle MQR, okay? MQR, here's MQR, and, we have to know that, look, all these angles are 90 degrees each, right? One of the properties for a square, the diagonals bisect angles. The diagonals bisect angles in half. So that means that if this angle, what I'm looking for is, again, PMS. So sorry. MQR. MQR, okay? And look, since I'm trying to find this angle, and we know that this is 90 degrees, note that this diagonal is going to split that segment into two, the angle into two congruent parts. So if this is 90 degrees, y'all, obviously this has to be 45. Diagonals bisect angles in half. So the measure angle MQR is, I'm going to say is, I'm not going to say equals, is 90 divided by 2. Actually, I'm going to write is, why not? Is equal to 90 divided by 2, or 45 degrees. Okay? Because, once again, with the square being a rhombus, that means that the diagonals bisect angles in half. Okay? For D, the measure angle PMS. So, PMS. How long is this angle here? Well, that's pretty straightforward because, look, the diagonals are perpendicular to each other. So that means that if they intersect at a 90-degree angles, which is PMS. So the measure angle PMS is equal to 90 degrees. Okay? Now, let me go ahead and get this PS out of the way now. Because look at this. PS. My goal here is to figure out what PS is, okay? We can't say that since this segment here is 5, that means that PS is 5. No, it doesn't work like that. And first of all, I should go ahead and draw that 90-degree angle there, okay? We got to figure out how long this segment is. And I'm going to go ahead and draw a triangle for you. Or I'm going to redraw that part of the triangle that deals with, with this. So we know that this angle here is 90 degrees. And we know that this segment here is 5, right? Because we already figured that out. That segment here is 5. And then this segment here is also 5. So how long is this angle? Okay, first of all, this is a right triangle. What we call this side here, we call it the hypotenuse. And the reason why we call it the hypotenuse is because this right angle is across, we call this the hypotenuse because the side is across from the 90-degree angle, okay? So we're going to call that C, because I don't even know what that is. That's my unknown. And hopefully you understand what we're trying to do here, because you have a right triangle and you're dealing with the letter C. you're going to have to recall something called the Pythagorean theorem. And the Pythagorean theorem states that if you have a right triangle, a squared plus b squared is equal to c squared. So a squared plus b squared, a squared plus b squared is equal to c squared. Again, I got to emphasize this. C is the longest side of the triangle, and it's always across from the 90-degree angle. So here's this 90-degree angle. What's across from that? This side. Or vice versa. So here's my side. What's across from it? It's that 90-degree angle, that dumb square. Okay? So now the question here is, okay, what's A and what's B, and what are we going to do with C? Again, my goal here is to figure out the unknown. It's like solving for X, right? Solve for C. So what A and B are, those are what we call my legs. Those are the, that's the non-hypotenuse in this case. So it would be, this is A, and then this is B. So I'm going to go ahead and start plugging things in. I got 5 squared plus, well, B is going to be 5 squared, which is equal to C squared. And then now, again, my goal here is to solve for that C, but something is in that way. It's this exponent of 2, right? And remember from Algebra 1, in order for you to get rid of that square, you have to take the square root on both sides. Okay, you have to take the square root on both sides. So then the 2 and the square root, they actually go away. So what am I left with? I'm left with that C on the right-hand side. And then I have that square root of 5 squared plus 5 squared. Well, I can just put this in the calculator, just easy. Again, you're just going to go, or not again, I'm sorry, I don't know what I'm talking about. But what I'm trying to say is you type or press the square root button, and you're going to write 5 squared plus 5 squared. Let me go ahead and see if I can do that on my calculator here. Basically, you're going to do second. Okay, you're going to press second, then the x squared button, and you're going to type in 5 squared plus 5 squared. Hit enter, and you got 7.07. I'm going to round to the nearest tenths, so C is equal to 7.1. Okay, and I know this is really, really confusing because I put literally everything over here when I should put everything over here. So let me go ahead and just move all of this so everything can be where it's supposed to be. Okay, so that is PS. That's the measure of PS. Okay, alrighty. Let me go ahead and take a look at this thing now. Quadrilateral JKLM with vertices JKLM is a parallelogram. Great, we can assume that this is a parallelogram. We're going to find the slopes of the diagonals. That's number 1. Okay? So, first of all, actually, what number 1 is, we should plot the points. Let's plot JKLM. So J is going to be negative 7, 2. Or, sorry, I keep screwing this up. Negative 7, negative 2. That's J. And then K would be 0, 4. That's there. What L is 9, 2. And then lastly, M should be 2, negative 4. Okay, so this figure here is a parallelogram. That's wonderful. What am I trying to do? Well, I'm trying to figure out whether or not this is a square, rectangle, or a square, rectangle, or a rhombus. Okay, obviously, it looks like a rhombus to you, yes? But we got to go ahead and verify that. So, one thing that I have to do is I got to go ahead and find the slopes of the diagonals. Because remember, with the slopes of the diagonals, we want to see whether or not they are perpendicular to each other. And if they're not, then it can't be a rhombus or a square if they're not perpendicular. wait, hold on. What am I trying to say? Sorry. Sorry. Let me go back because my brain just like froze. What I'm trying to say is, if you're trying to find the slopes of the diagonals and if they are perpendicular, it's either a rhombus or a square. And if not, then it's a rectangle. And let me go ahead and just, show you. My diagonals are K and this should be M, sorry. That should be M. So the diagonals of KM and also, man, I'm not labeling things. I'm so sorry. That should be L right here. And then JL, okay? So I'm going to go ahead and draw those diagonals there. I'm going to go ahead and find the slope. If they are perpendicular, once again, if they are perpendicular, then it can be a rhombus or a square. Can't be a rectangle. Okay, let's go ahead and find that slope. So the slope of Km, let's go ahead and find the slope of Km. That's going to be your y2 minus y1 over x2 minus x1, which is going to give you negative 8 over 2, simplifies to negative 4. Okay, and then I'm going to go ahead and find the slope between J and L. So here's J and here's L. So that's going to be y2 minus y1 over x2 minus x1. That's going to give you 4 over 16, reduces to positive 1 over 4. And look at this. These things here are perpendicular to each other. They are perpendicular to each other. And do remember how perpendicular works. Well, opposite sign, flip the fraction. If I were to look at negative 4, well, what's the opposite sign of negative? It's going to be a positive. And how do you flip the 4? Well, you just, make the 4 come the bottom, and then there's going to be a 1 up top, which is 1 over 4. It's perpendicular, okay? So if it's perpendicular, right, it can either be, a rhombus or square. And once again, I totally get you. This looks like a rhombus to you, so that's great, but you're going to have to verify whether or not it's a rhombus by using these things here. I think we're just going in-depth the theory and such here. So I found the slopes of the diagonals. Now I'm going to go ahead and determine whether or not the diagonals are congruent. And by doing so, I have to use the distance formula, which is D equals the square root of x sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2, the quantity squared. Okay? So, again, if the diagonals are congruent, I got to determine if the diagonals are congruent, and the reason being is if the diagonals are congruent, then my possible choice would be that this figure is a square. If the diagonals are not congruent, then this figure is a rhombus. So I'm going to assume that you know how to plug things in and you know how to use the calculator. I would recommend, if you don't remember, you go back to Unit 2 and find the video where you basically just plug it all in the calculator, okay? So, let's go ahead and figure out the diagonal. Let's go ahead and figure the length of the diagonal of JL, okay? So, the diagonal, or the distance between JL would be D is equal to x sub 1 minus x sub 2 plus y sub 1 minus y sub 2 quantity squared. And that's going to give you approximately 16.1, okay? So it's DJL is equal to the square root of x sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2 quantity squared. That's going to get you 16.1. Now, I want to go ahead and figure out the distance of Km, because that's my other diagonal. So I take the square root of, okay, well, it's going to be, again, x sub 1 minus x sub 2, quantity squared, plus y sub 1 minus y sub 2, quantity squared. And that's going to give you approximately 8.2. So are these diagonals congruent? No. So what does it mean? It's perpendicular and diagonals are not congruent, so therefore this figure is a rhombus. This parallelogram, JKLM, is a rhombus. Okay? So this was basically to test whether or not you understand your properties.